Hello, everyone. I hope you guys are doing well. Hello again. One more time. We are going to talk about time series. No matter how much I want to finish this, yeah, in terms of providing the material and then sharing with you what I can find as valuable. The topic is so wide. I'm struggling actually to be able to finish this. So let's see. I just shared the material, the link to material, GitHub link to the material with you. For those who just arrived, I'm going to post it one more time. Okay, so you can find the material under week 4. I put, again, we are going to use very small data sets and the notebook, Jupyter notebook. If you want to write the code, type the code with me, which I thank you, Edward. So which I strongly recommend typing the code. So a couple of things. I have been looking at different books. I tried to look at recent books using Python. So some of the material I'm talking about, I utilized Jason Brownlee's time series forecasting. It's an introductory book, very introductory. The Python code is very simple to follow and understand. So if you are totally new into area, it might be a good source, but very introductory, okay? And another one is, I like the books from Manning. So the way they use Python to explain the topics, I like their machine learning books, but this is also, again, some of the topics, the order of the topics I might prefer in a different way, but it's a good book to begin with, time series forecasting in Python. Again, it's an introductory book. A little bit, the level is a little bit higher than the first one. And if you really want to deal with industry level code and bigger data sets, this modern time series forecasting with Python is a good book. That, as far as I can see, I think the book is using a single data set, but it's a big data set. I mean, large data set. Use the word large instead of big. So it's using a single data set. The code the use in the book is a little bit advanced. So if you are already comfortable with main topics and Python, I think this third book might be a good option for you. Again, I tried to look at only the recent ones. I don't know about older. I didn't check the older ones. If you want to listen to like 10 minutes long, really intense and to the point mathematical explanations of the topics, Rhythmic Math, I found that channel very useful. I mean, extremely well explanations. I really enjoyed listening to his explanation. So that's another source that I would recommend if you really want to get into this a little bit more, a little bit deeper. Okay, so what are we going to do today? What we're gonna do today is we are going to, actually, I remember talking about trend in our first meeting. Again, I'm gonna go back to trend, but this time, in addition to trend, so we're gonna do a little bit coding, a little bit more than what we did earlier. We're gonna look at trend. We're going to look at seasonality. So when we are given a data set, a time series data set, the data set is composed of a trend, which is going to be going upward or downwards, changing by time. A seasonality, which is a periodic deviation in the data set that you observe, like temperatures, right? Temperature in a yearly temperature is seasonal data set. Seasonality. So we are going to try our best to capture trend and seasonality in the data set, and then we want to remove it. Those are components of our time series data sets, all right? So these are pieces of information that we want to get from the data set. Actually, our data set is sometimes summation, sometimes summation if it's an additive model, and sometimes multiplication of these different components of the data set. So we're going to talk about seasonality, and I'm going to finally talk about stationarity, what makes a data set stationary, how we can check stationary. So for that, I did my best to come up with the Python code that we can run a stationary test using just Python code, like again, not without using any library. But so I'm going to talk about it when the time comes. It's not that easy because there is a specific distribution which is used, and that distribution I couldn't find it with at SciPy. SciPy is not providing that distribution. I actually digged a little bit deeper. I checked the Python library for ADF test, and then I checked the code. Actually, in the code, they explicitly list the distribution. Okay, so they are not using any Python library to pull the distribution data. They explicitly use the distribution in the code in the class. So that's why I did my best. I also checked some other resources. I think by mistake they are using T distribution. Anyways, so in short, I tried to give you from the scratch Python code for running ADF test, but I wasn't able to do that. Okay. All right. So let's go up and then start talking about this time series analysis. Again, I shared the code, the data sets with you, and this first part I remember doing a part of this in our first meeting. Maybe it's going to be a repetition of what we already did, just for maybe 15 minutes. So what I'm going to do is I'm going to read a data set. The data set I also shared with you, monthly carbon dioxide concentrations. Again, these are very small data sets, but enough for us to actually see the effect. Okay, so I will start with importing pandas as PD, and I'm going to import. Again, I'm assuming that we are totally new into this, and there is no. So I'm just going to use the basic Python knowledge. All right. So import NumPy as NP, and then let's now just read our data set. So pd.read CSV. Remember from our previous meetings, here, if you like, you can parse the date component of the data set, right? But for now, we are going to just read the data and then take care of the date component ourselves. Okay, so let me, I'm just typing the exact name. Let's see, capital O, 2, and then concentrations. CSV. Okay. Yeah, so SA, that's what I was talking about. Stats models has ADF test. What I want to do was, instead of using stats models, can we create the test from scratch? So I couldn't, and then I went ahead and checked stats models on library. I digged a little bit deeper. I found out that they are using the DF distribution just as a list. So they just have the list of the distribution, okay? So that's why I couldn't write the code from scratch for you. Okay, so this is the data set, and let's just read the data. Yeah, Michael, you already began the question. So yeah, I will talk about this when we get a little bit tired. Okay, thank you for the question. So let me get the data set. So this is our data set. As you see, I have the year and the month, and then let's check the data types. So the carbon dioxide is a float number. As you see, year and month are all float numbers. Year and month being float number. A decimal number doesn't make too much of sense, so we are going to take care of that in a minute. But again, these are small things, but it's going to take your time. So that's why all the mathematical explanations, I put everything here. So Ricardo, so YouTube, Ritwik Math, I really like this guy, this gentleman's explanations. Okay, and Michael, I'm going to get back to your question. Okay. So let us check if this data set has any null values or, I don't know, infinite values. So there is a reason for that. Again, these are simple stuff that you need to do every time you deal with a data set, but I'm just repeating here, assuming that we are all new into this. Okay. So I'm checking if there is any, I'm specifically checking for these values. If you like, you can simply check if there is any missing value or not, but I'm just specifically checking for these values. So it looks like carbon dioxide year and month. There are 13 rows of, at somewhere, there are 13 rows missing values. I actually checked the data set. So the CSV file, actually, there are empty rows, all right? Okay, so the reason why I put this in here is because year and month are floating numbers, which they are supposed to be integers, right? So it doesn't look right. If you want to change the data type into integer, and then if you have missing values, it's going to give you an error. So you have to take care of the missing values first. So that's why let's try it. Let's try it. So I'm going to take my data, and actually you can spend some time on this and then see why it is not working if you did not check if you have missing values. So what I'm going to do is I'm going to turn year into integer, and then what do I have else? Oh, month. I'm going to turn month into integer too. So let's see what's going to happen. So when you run this, it's going to give you an error. It says blah blah blah, cannot convert this and that. So you need to make sure that you don't have any missing values before you run this one. Okay. So let's take care of the missing values first. If you want to see the indices of the missing values, that's another thing that I wanted to point out, because we are going to use indices a lot when we are dealing with time series data sets. So that's why, again, I may be taking a long version of the code, but I want to make things as explicit as possible, okay? So what I'm doing is I'm checking if there are any missing values in any of the rows, and then I am taking the indices of those rows, and then turning that into a list. Okay, first of all, let's see what happens if we don't do this. So I need to delete this one. So let me see, any data is no. I need to put this one here, I think. Yeah, so this is the indices. It's an array. Let me turn this into a list. If you like, later you can use index numbers as a list too. So that's what I just wanted to show you, okay? And then if you are curious about what happens with the index number 8, right? So you can check directly using LOC, right? And then see that we have missing values there, okay? Let's also check our data shape. And then we have 174 rows as of now, but again, these are all missing values, okay? So if you like, now you can eliminate the missing values, right? And then check the data shape one more time. So we are done with the missing values, right? So they're gone. Again, there are different ways. I remember doing this before. There are different ways dealing with the missing values, but I mean, let's just use this one. So I want to point out something here, which is going to be a problem later on. So, but once we move down, we are gonna realize it's a problem. So we need to come back and fix it. But before going through that, let me just show you something that, again, for those who are new into this or just began like me, okay? So as you see, this is index 7, this is index 9, index 8 is gone, right? So we deleted index 8. That's why I wanted to show in here. Index 8 is just all the missing values, right? So we deleted it, but the indices are not updated. So later on, if you are using indices to run a loop over the rows, so for example, we are taking first difference of a certain column. Let's say I'm taking the first difference of carbon dioxide in a loop. Again, you can do this in many different ways. You may not want to use a loop. That's also fine. So you can simply use a function. But let's say that's what we want to do. Then when you are running a loop on the CO2 column using index numbers, then you're going to have a problem here. Because index from 7 to, let's say, for loop is taking an I value, which you are using for the index. Then I is 8, you don't have the corresponding data point. All right, so that's why you need to take care of that. And then to the way we're going to take care of it, we are going to reset the index, right? So let's reset the index. Data.reset index. So let me make this data close. Let's see now what happens. Now you see I took care of that gaps in the indices, right? So actually it just assigned new index. But here, let's also say I want to drop the old index. Okay, this is the old index. I want to drop it. Let's do it that way. Oh, we should have done that earlier. So sorry about that. Let us very quickly drop this. Then, okay. So now we took care of the index problem, and my indices are following a sequence, which I'm happy about it. Now let me change the year and month into integers. And now year and month are integers because we don't have any missing values. Again, this is just data manipulation, but I think it's helpful to know if we are going to deal with what is that? Time series data sets. Okay. All right. So no questions here. Okay. All right. No questions. Okay. Now let's talk about the trend. Okay. Let's talk about the trend. So what I'm going to do is, again, we did this part. I remember doing this before, but it's okay. What I'm going to do is I'm going to plot my data, this carbon dioxide data. Okay. So let's see what we're going to see with this one. For that, I'm going to take my data and then take CO2, and then let me just plot this. So as you see, my data has, I mean, visually, right? We can easily see that my data has an upward trend, right? So we need to take care of this if we are going to, I mean, look into this data set. Well, in the long run, so I think this is 10 years of data set. In the long run, we see there is this trend. If you want to zoom in and then see it for maybe 2 years, right? So you can do this again. After this one, we are starting with a new material. Okay, so this is repetition of what we did earlier. CO2. Again, I am going to this time choose only a certain date. So data. I'm going to choose year is 1980. Okay. And let's also choose one more, 1981. So let me make this. Again, you can make this in 1980 and 1981. You can do that way. Again, let's do this very explicit, okay? 1981. All right. So let's see what we're going to have. What I'm going to do is I'm going to take this and then plot. Okay. So in the long run, there is a trend. In the long run, I can observe the trend. But if you just focus on 2 years, you may not observe this trend. Okay. So that's why when we are looking at our time series data sets, it is better to zoom in and zoom out so that we can have a better visual, perception of the data set. Okay. All right. Okay. Now, what are we going to do? What are we going to do? What is next now? What we're going to do is we are going to try our best to capture this trend in the data set and then eliminate it. So there are reasons why we want to do this, right? So we are going to work on this data set clearly. So there is a very clear trend in this case. We are trying to find out the relationship between time and these values. And there is a trend here. So I want to remove that trend and then work more on this data set. So this is a very obvious relationship, right? So there is a trend in the data set. I want to capture that trend. So how can we get rid of the trend? Well, if you like, you can just fit a linear regression model here. And then that linear regression model basically is going to give you a straight line, which is following this trend. That's one thing we can do. Another thing we can do is we can take a first difference. First difference means I can subtract tomorrow's data from today. That way I can eliminate that constant trend that I'm adding up with each time, each data point at time t. So actually, if you think about it, what we are doing is I have data points scattered along the time, and then I'm adding those data points with a constant each time. So here constant is added once. The next time it's added twice, and then 3 times, and then 4 times. So then we are having this trend, right? So One way is, again, let's fit a linear regression line, and then we are going to do a little bit more on what else we can do. So let's begin with a model. Let's use a model first. Sometimes checking if we have any questions. Okay. So let's fit the model before the, yeah, I'm going to talk about it later on. So let's take scikit-learn linear model. When I was trying to, so again, you can fit OLS regression using different libraries. In this case, we are not really into any causality, this and that. We just want to capture the line. So I'm just going to use scikit-learn. Okay, and then let's call this trend model. And let me instantiate my model, linear regression. Okay, and let me run this. So I have the model. Now I'm going to take this model. Okay, just let's wait for a while. Yeah, and then I'm going to fit on the data set. Now, fit on what, right? So what are we going to fit? So normally when you fit a model, right? So what we need is we need the feature set. In general, in machine learning, right? We have the feature set called X. This is the feature set. And then we have Y, which is the target variable. Okay, so what is feature set in here and what is target variable? So in this simple data set, what we have is on the x-axis, we have the time, right? We have only the time. And on the y-axis, we have the carbon dioxide levels. So basically, my target variable is CO2, and my feature set is very simple here, time index, right? So given time, I'm trying to predict carbon dioxide level. Okay, so that's what I'm gonna do. So then let me make this guy. So let me first find my data. So data time, which is y. Okay, so let's call this y. Sorry, y equals data. This is not y. This is x. X equals data dot index. Okay, so let's use this one, and then indentations one, and then let me also use y equals data CO2. Okay, so let's use these two. Now I'm going to fit my model on x and y, right? And then let's see if it's going to work. Okay, so let me run this, and it gave me an error. Let me see. It says is expecting a 2D array, but got 1D array instead. So this is my time index. So scikit-learn, when you are fitting a model with scikit-learn, it is expecting X be a two-dimensional array. Right now it is single-dimensional. Let's check the shape. It is single-dimensional, so I need to add one more dimension into this. So there are different ways of doing that, but let's simply follow the suggestion of scikit-learn. So what it says is use reshape -1, 1. -1 means no matter how many rows this data set has, add one dimension as column. So that's what we are going to do. So x dot reshape. Again, -1 means I don't care about the number of columns, the number of rows, but I want to have one column. Okay, and then it gave me an error. So let me see. Because, okay, that's another thing. So this reshape is going to work on NumPy arrays. So right now the data type for x is some integer. It's not an array. So let's turn this into a NumPy array. So let me do this right here. Okay. Okay. Again, these are very small things. These are really small things, but it is going to give us trouble. That's why I'm spending time on them. So now we have, we reshaped our data set, all right? So let's say X equals this, and let's fit our model. So I fit the model. The next thing is, I'm just curious about the coefficients of this model. If you want to see how the line is going to look like. So this is the model. And then I'm going to check the coefficients. So it has two coefficients. It is one coefficient because it is only one variable. And also it has this intercept. Okay, so I got the model's coefficient and the intercept. Now the next thing is, what I'm going to do is I'm going to subtract. Okay, I'm going to subtract. Given this model, I'm going to predict what is given this model. So the model I found is a linear line. So given this linear line, I'm going to use time index as my X, and then I'm going to predict Y. Okay, basically what I'm doing is for this time index values, I am going to calculate corresponding Y values. So basically what I'm doing is Y equals 0.12 times X plus 329.45. So that's what I'll be doing when I say predict, okay? And then I'm going to subtract this Y value from my original data set, which is CO2 level. So this way, I'm hoping that I'm going to eliminate this trend from the data set. What I will have will be the residual. So the data minus trend, okay, that's what. So I'm expecting that residual be having not have any seasonality. That's my expectation. If it has any seasonality, then I have to take care of that too, right? So let's now work on the residual. Okay, from time to time I'm checking if you have questions, and please let me know if you have any questions. I mean, if you want me to go a little bit faster or slower, so just let me know. So what I'm gonna do is I'm going to first of all predict for my data index. Remember, data index is X. Given this X, what is the prediction? Okay, that's what I'm gonna do. So let me take my model, trend model, and then I'm going to predict using this model. I'm going to predict the values for my for X. I already took care of X. Again, if you don't reshape it here, it's going to give another error in here. So make sure that you always give the feature set as a two-dimensional array for scikit-learn. So let's call this my thread. Okay, so this is my prediction for each data, I mean time index. Okay, next I'm going to calculate my residual. Residual is whatever is left when I take away the what is that, the trend from my data set. So again, my data is data CO2. Now again, let's try together and then see what's going to happen. So if I subtract from this my prediction, let's see what's going to happen. So, oh, it worked. Okay. So I get my residuals. Now what I'm going to do is I'm going to take these residuals and then plot it. Let's see if, and it did. Okay. So this is my residuals. So, I mean, as you see, I still have some ups and downs, some cycle in here, right? So it is not totally, so yeah, I eliminated the trend. Let's go all the way up. So I took care of the trend. I know I have some component of the data set which I know about now, but then there is this another thing that I can easily maybe take care of, or I can easily get information about. What is that? This cycling thing. Okay, so in the next section, that's what we are going to work on. All right, that's what we're going to work on. But before getting to the next section, what I want to do is, can we take care of this trend in a different way too? So, okay, so that's what I want to do next. What I'm going to do is I'm going to this time use first difference. So first difference is basically, so let's say my data is a function of time. okay? Y is a function of time. This is actually, my assumption is this is actually some constant times the data point from previous time period, okay? And then plus some constant, okay? So if I take difference between, so constant and then plus some error term, okay? Let's call it E of t, right? Error term, let's call it just E, okay? But this is E of t. Let's say E of t because then this is a random number for each data point. It's a random number for each data point, so that's why. So then y t minus 1 is a times y t minus 2, right? Plus some constant, which is adding this trend, plus another error term. So what I want to do is I want to subtract yt minus 1 from yt, okay? Yt minus yt minus 1. So when I do this subtraction, this term is going to go away, okay? These terms, so I will still have like, I don't know, a times, so yt minus, so I will still have something here, okay? T minus 2, and then some error term, okay? E, let's call this not E of t, so let's just keep it that way, E of t. Actually, these two subtracted terms is another random number, but let's just keep it that way. Okay, so this is what I want to do with subtraction. So I want to get rid of this term in here, which we are thinking that creating this what is that? This trend. Okay, so that's what we're gonna do. So let's do it then. I'm going to create a for loop. So this for loop is going to give me the difference values that I am hoping to find. So let's create a let's be consistent. Let's create a empty list. And then what I'm going to do is, again, you can do it this in different ways, all right? But let's use a for loop and then see everything clearly. So what I'm going to do is I'm going to loop over all my rows in my data set. So starting from the first one. So normally what we do is I can simply write this, right? So data dot shape 0, right? So that means I'm going to loop over my data points, data shape 0. So let's see what it is. Data dot shape is giving us number of rows and columns, and 0 is giving me number of rows. So what I'm doing here is I'm starting from the very first row till the last row, right? But because I'm going to take this difference, I want to start from the second row so that I can subtract the first row from the second row. So that's why what I'm going to do is instead of starting from 0, I will set my starting index to 1. Okay. All right. Next, I'm going to take my data, which is here. And by the way, let me also show you what I'm going to write in here. This is my data. Now I'm going to pick a specific row, and the value in that row for carbon dioxide. Okay, so that's why I'm going to use this log. Okay, this is the specific row, let's say 4. This is the 5th row, and then this is the value in that 5th row. This is the value of carbon dioxide. Okay, so all right, so that is what I'm going to use, data.log. But instead of 4, I'm going to use I. I is corresponding to the index of the row, and in that row, I am going to pick the value for carbon dioxide. Now, I'm going to subtract from this. I'm going to subtract the data point 1 above, okay? So that's why I'm starting from index 1, because index 0, then this is the first iteration of this for loop, I is going to be 1, and then I'm subtracting I equals 1, and then I minus 1, right? So this is the data point before, in the first iteration, this is the data point at the 0 index, and this will be the data point, the row with the first index, right? The index number 1. And then let me assign this to some value, and then I'm going to append this list. Okay, so now I got my first difference. Let me just I don't know if I already imported PLT, but import matplotlib.py plot as PLT. Yeah. So PLT dot plots with CO2. And it gave an error I in range. Okay, so as you see, even with this first difference, I'm able to get rid of the trend. But in this case, I mean, I don't have this extra information which I got in here, right? So here I have some estimated line equation, right? So I don't have it in here. Okay, let me see if maybe there are two questions. Why we want to remove trend? What we want to do is Satindra. So think of this. We want to know about our data set. So trend is one of the components of our data set. Instead of removing it, let's call it recognizing the trend and putting it aside. So I just strip the trend away from my data so that I can look for what additional in my data out there so that I can discover. So I'm not actually throwing away the trend, but trend is one of the components in my data set, which contributes to the values of my data points. If you were to fit another linear regression line to the residuals, will the slope of that line be 0? That is the expectation, right, Andrew? So of course, here, as you see, a linear line is most likely going to be a straight line from 0, most likely, because the mean value, as you said, is cycling around 0. But if you were to fit a polynomial, right, a polynomial, of course, you will be able to fit another linear regression line, but this time it's going to be maybe carbon dioxide and then time index and then square root of time index, maybe the third power of time index. So you might be even we're gonna see that too. We're going to see that too, Andrew. We might fit a polynomial of certain degree, which is going to fit to this data so that we can remove whatever is left in here. Actually, that is going to give us the seasonal information. Again, we're going to learn hopefully today. All right. Let me see if, yeah, now it is time for us to look at seasonality. Again, let's go back to our data set. I will use the same data set. So let's see what we have. Just remember, so we have this and that, but I think we should we are going to take care of it. So let me see what why we didn't data. I thought we already took care of the here. Put this down here. Okay, so all right, so I have my data set. So what I'm going to do is I'm going to use the residuals from the previous section. Okay, so and then I'm going to add this to my data set. So let's see, this is residuals. Okay, so I'm adding a new what is that column. Let's see how it's going to look like. So this is my data set, original data set, and these are the residuals that I found for my data set. In addition to this, because I recognize that even looking at this residual, I recognize that there is some seasonality in my data set, right? So what I'm gonna do next is, again, we can approach this problem in different ways, but what I want to do is I want to work on the seasonality using quarters. Okay, so you can work on this monthly, but let's get, we are going to actually work on it quarters by mapping the months into quarters. That's what we're gonna do next. Again, so I'll just show you how you can use a dictionary and then using a lambda function. So my goal is just to show you that you can do these things using lambda function and dictionary. So let's do it very quickly together. So I'm going to first create a map. This is nothing but a dictionary, right? A dictionary is always contained within curly brackets, and this is my keyword, and this is the value, okay? Q1, right? So I'm gonna have 12 of these. Let me just copy them, okay? And then you can also copy and paste. Let me make this 2, and then let me copy this again. So this is 3, and then this is 4, and then 4. Let me go to the next line. Let me copy this whole thing. Okay, so this is going to be 5, and then 6. Sorry for this taking a little bit long. Okay. Oh, I did all wrong. So, so the first month, right? The first month, it's Q1, right? Yeah, I was also that if you are mapping everything to quarters of 12, then why we are doing that, right? So the first 3 months is Q1. Let me, okay, anyways. And then the next 3 months will be Q2. And next 3 months will be Q3. And the last 3 months will be Q4. Okay. So we have our dictionary. Perfect. Okay, let's run this. And it gave an error. All right. Next, what I'm going to do is I'm going to create a new column. Okay, it is quarter. All right, a new column. But this new column is going to be as following. So I'm going to take the month column, all right, and I'm going to map these numbers to corresponding quarter values, and then I'm going to put that quarter value into this column. That's how I'm going to create the quarter. So to do that, I'm going to map. When you are using map, you can use a dictionary, and to be able to use a dictionary, I'm going to use a lambda function. So what is going to be is this m is going to be the value corresponding to that m. Okay, so map month, quarter, map get m. So before running this, let's see what this is doing. Okay, let's see what this is doing so that we understand what's happening. So this is my dictionary, and this is one of the values. Let's say I'm looking at the 4th month. So the 4th month, this one, its value is Q2. So basically I'm putting the keyword and getting the value. That's what I'm doing here. Okay, and I'll be doing this row wise. At each row, I'm going to check the month value. And then for that row, I'm going to insert the corresponding quarter value. That's what I'm going to do here. And perfect. Okay, let's see how my data set now looks like. Okay, now I have the quarters. Why are you using get and not accessing dictionary? So I didn't try it that way. But let me try it that way, but I don't know if it's going to work. I'm not sure if that is going to work. Let's try it here. Okay, for that, what I'm going to do is, now that you asked for this question, and then I'm also curious about that, let's just do it. Okay, and this one too. Okay, Residuals are already there. Perfect. Yeah, they are here now. So this is the data. Okay. Oh, still, okay, let's get rid of that here. And this is my data. Now, so you are saying, what you're saying is instead of this, yeah, let's do it. Yeah, it worked. Thank you. Yeah, thank you. It worked, but so Aditya says, I think get outputs none if the index is not found in the dictionary. That might be a reason, Aditya, but I don't know the answer for that. But yeah, it looks like in this case, I don't have any missing value in the dictionary. In this case, it worked. But you might be right. Get might be. So if you simply use this, if I don't have the value in the dictionary, I might have some error. And get might be just preventing that error. Anyways, thank you. Thank you for the input. All right. So we got the data set ready. Now, what we're going to do is we are going to work on this quarterly data set. Now, what I'm going to do is I'm going to take my data. And when you work on seasonality, most of the time, what you're going to do is you are going to group your data by, let's say, in this case, I see that in a seasonal data set, right? So if you look at this data set, in a seasonal data set, so I expect the same kind of movements in my data in the same quarters, right? So in the Q1, if this is a seasonal data set, in Q1, I expect the same kind of movement, right? So that's why I'm just curious about if my data has different mean and standard deviation values across different quarters. If that is then there is seasonality. And that is violating actually stationarity, right? So if certain parts of your data set have different mean and standard deviation values, that is violating stationarity. That's why if there is seasonality, that data set is not stationary, right? So what we're going to do is we are going to group our data by year and also quarter. So let's do it first. I'm going to group by data. And by the way, these decisions, I'm taking these decisions by looking at the data. And most of the time, you are going to make trial and error. Okay, so year and quarter. Let's see. Year and quarter. Okay, so if you just group your data by, it's just going to give you an object. So let's run this. It's just going to, you have to use some aggregate function on group by. So this is one of the things I always find we are confused with. So it's not going to return any number to me. So from this group, when I group my data by year and quarter, what I'm doing is I put all the data points in the same year and in the same quarter together. Okay. So basically, I am going to put the same months into, I'm just taking 3 months of each day, each year. That's what I'm doing now. Okay, so from this, I am going to pick the residuals because I already took care of, I'm working on residuals now because I already took care of the trend. This is what is left from my data set. So now I'm focusing on this part, which is the residuals. So I will focus on residuals here. Okay, and what I'm going to do is I'm going to take the mean and standard deviation of residuals for each year and quarter. Okay, so for that here, after this point, this group by is going to give us numbers. All right, and you can put here sum, max, mean. Here I'm going to put numpy mean and numpy standard deviation. So what I'm trying to do is I'm trying to find the mean and standard deviation per quarter. So let's see. When I do this, as you see, this is my data for 1974. These are the quarters. As you see, for 1974, I'm missing quarter 1. And this is the mean value for that quarter in that year. All right. So that's what I found. Okay. So let me just, what is that? Let me assign this to some value. Okay. Let me assign this to some value. So let me say seasonal data. Data. I just wanted to print it so that we see what it is. Okay. Now, if you like, you can. Oh, let us. Like us seasonal data. Let's see one more time. So this is mean and this is standard deviation. If you like, you can change the names of these columns, make it more meaningful. So that's what I'm gonna do. Columns equals. So these columns, I'm gonna take that, and then these columns. Let's see if it's gonna work. Let's see if it's gonna work. I'm gonna say quarterly mean. This is going to work. Let's check our data one more time. Yeah, it works. So this is my year, this is my quarter. By the way, year and quarter are now indices. I have two indices here, okay? And then these are two columns. Why do you choose quarters? Again, it's like seasons, right? So I just want to start from somewhere, SA. So I know that there are seasons like mostly following the quarters. It's like, I mean, we have quarters we are using in financial data sets. So I'm just using quarter as one metric here. So one time unit here. If you like, you can group 2 months together or 3 months or 4 months together. Okay, so that's why I said it takes some trial and error to see at what level is going to give you the best seasonality information. Here I just chose quarters because it's something that people from different disciplines understand what quarter is, and I think it makes sense in here. We are simply dividing year into four what is that 4 pieces. And this is carbon dioxide level. Again, depending on the season, carbon dioxide level might change depending on winter or springtime, right? So that's why we chose quarter. When you have daily and quarterly data combined, do you interpolate or quarterly data across the days, or do you remain constant until the next month, until the next quarter? Okay. Again, depends on what you are doing, Michael. So when you have daily and quarterly data combined, means in one column you have daily data, in another column you have quarterly data. Do you interpolate or quarterly across the days, or do they remain constant until the next month? So what we are saying is the data of different things. Let's say I have data on stock market daily, and then I have data on company returns quarterly, let's say, right? So in a data set, I have 2 columns. One is daily data, the other one is quarterly data. Yeah, so in that case, if you are dealing with databases, of course, I'm going to interpolate. I'm just going to copy, actually, not interpolate. I'm just going to copy that, because that quarterly figures are company's feature, right? So I'm just going to copy it. Again, it's a very open question. Depends on what you are doing. Yeah. Thank you, Yasser. Thank you. Okay, so let's continue. We got the quarterly numbers. Oh, it's too long. Okay. Now what? So I want to just see my data set in terms of quarterly mean. That's all. Okay. So let's do that. I'm gonna. What was the name of the data set? Seasonal data. Okay. Slowly we are getting to the end of this section. Okay. Quarterly mean. It's a quarterly mean. I hope the name is correct. Quarterly mean. Okay. All right. Let me take this and then plot. Yeah, this is the quarterly mean of my data. Again, I mean, from quarter to, so as you see, I mean, when you look at the data set, it follows a certain seasonality from one quarter to another. So it is high in certain quarters, it is low in some certain quarters. Again, these are all visual inspection of our data set. We'll do we'll do a little bit more on that. So if you like, you can even plot the standard deviation too. These are two very critical metrics for any data set we are using, mean and standard deviation. That's why I chose them. And we choose it actually, quarterly. Let me just copy this. And you'll see the same seasonality in the mean as well. If mean and standard deviations are changing across time, that means that data set is not stationary. Yeah. Okay. So slowly, so we understood more and more about our data set, right? We understood more and more about data set. If you like, you can create a box plot. Box plot is going to give you even a more aggregate picture of your data set, and it might be very useful. Now, here it's hard to maybe, we can see that it's going up and down, but I don't see in which quarter it is going up or in which quarter it is going down. It's hard to see that. Then let's create a box plot. Box plot is going to show the whole, the picture with only the 4 boxes, right? So again, you can create box plot using Seaborn, but because all these lectures I used Matplotlib, I'm gonna continue using Matplotlib. Again, otherwise it's much simpler using SNS, but I'm gonna use Matplotlib. So I'm gonna use box plots. So my suggestion is, again, if we are new into this, please learn using one library very well, and then learn another library. I think it's going to be more useful. My personal suggestion, it's going to be more useful. So what I'm going to do is I'm going to create a box plot of my data set. And for that, I will have 4 quarters, right? So I'm going to plot my data when data quarter is equal to Q1. Okay, so I'm going to take this data and then plot the residual. Box plot of residuals. So let me run this. And list object has no residuals. I don't have data quarter residuals. I didn't add the data to residuals. Let me see. I think I added it. So let's see. What is this? Is it smaller? Ah. Let's see. Data residuals. Go back. Can you see if maybe you want to use? No, I think I'm using the original data, but the list object. Oh, it is. Hold on. I see. Okay, I'm trying to get from a list. I think it will work now. Yeah. So this is, yeah. Thank you for the yeah, Sasha. You just saw what I saw. Thank you. So I'm going to repeat this. So that's why I just wanted to first put one box plot. This is for only Q1. So I'm gonna do this for 4 quarters. Okay, let me just copy this. Okay, this is Q2. This is Q3, and this is Q4. Hopefully this will work. So I have 4 box plots, which is showing me this is Q1, Q2, Q3, and Q4. The median values, right, are totally different, right? So there is across different quarters, my data has different mean and also as a different standard deviation. So this the length of the width of the boxes is telling me the spread of the data set. So if you like, again, you can also add labels. So let's very quickly add the labels so that you know how to add the labels too. I'm just going to add the label using xticks, and then I'm going to leave it right there. I don't want to get into any further with box plots. 1, 2, 3, 4. So these are these numbers 1, 2, 3, 4. I'm just going to map them into this. Q1, Q2, Q3, and Q4. Okay, perfect. Thing we're done. Okay. So again, this figure, what is the interpretation of this figure? This figure is telling me that my data set, after I remove the trend, still has a different mean and standard deviation across different, what is that? In this case, different quarters. But these quarters are representing different parts of the data set, right? But these different parts are repetitive. Like every time it is quarter one, every time it is quarter two. In the figure above, I see that this is seasonal. In this figure, I see how the mean and standard deviation or the spread of the data for these quarters is different. Okay. All right. So then what? Then what are we going to do about this? Then we are going to do some additional operation on this data set to remove the seasonality. Now let's begin using another data set. Maybe I can go back to this data set in the next section. Okay. I'm just checking if we have any questions. All right. I'm just going to use another data set and then repeat some of the things we did as an exercise, and also some what is that? Some different things as well. So this time, what I'm going to use is this data set, daily minimum temperatures. Okay, that's what I'm going to use. So let's read the data set. Read CSV, daily minimum temperatures. Okay, so I'm going to read this daily, and then let me assign this to data 2. Then this is pandas. Then what is it? Daily minimum temperatures. Okay, I got my data set. Next, I just want to see how my data set looks like. Okay, so this is the date, this is the temperature. So data 2, but types. And date is an object. It's a string. It is not a date time object. So I want to turn that into date time object. I could have done this as I was reading the data set. Here I choose to do it outside it. So that's another exercise. I'm doing this on purpose. If you like, you can read the data set as you are reading the data set. You can just parse the type of the date into a date time. But let's do this ourselves manually. So for that, I'm going to use from date time, import date time. And then I'm gonna say what is the data 2? Data 2, the date. Okay, so it's going to be td.date time. It's actually 2 date time. I'm not using date time here. I don't think I need this one. Let's see. And then that one. So I'm going to take my data 2's date, okay, and then turn it into date in this format. So this format is important. So what kind of format you are expecting? So first, it's going to be year, and then dash, it's month, and dash, it's day. Okay, let's see if this will work. Let's check our data one more time. Okay, it works. So this is our data. Let's check the type. Now date is date time. One more thing I want to do is I want to replace these indices with date. I think we did this before, but let's do it one more time. Data 2, I'm going to set my index, okay, into date. And I want this happen now, okay? So okay, here is my data. Perfect. Okay, I got the temperature. We used this data set before, I remember that. So let's now plot this data set. plt.plot data 2. As you see, it's there's some perfect looking seasonality here, right? Similar to our previous data set. I don't see like a trend in here. This is raw data without any, what is that, detrending it. So it doesn't tell me that the temperature is increasing steadily. It's saying that the temperature is cycling. Like, see, there is seasonality here. So now let's work on this one. What I'm gonna do first is, for removing the seasonality, there are a couple of things I can do. Similar to what I did for detrending my data set. If I want to remove the seasonality from my data set, what I want to do is, I'm going to subtract the temperature of today from temperature of exactly 1 year later. Okay, so because that's what seasonality, it's like a sinusoidal wave, right? So 1 year is one full period, right? So what I'm going to do is I'm going to subtract today's temperature from exactly 1 year later's temperature. So this way I want to remove the seasonality in my data set. Okay, there are a couple of things we need to pay attention to, but let's just attack the problem first and then see what kind of things we should actually think about. I'm going to take my, let's say, diff2. This is an empty list. So I'm going to be putting the year is 365 days. Okay. And for I in range, I'm going to start from, in my data set, I'm going to start from 365th index number, because I'm going to subtract today's temperature from exactly 365 days later. So I'm going to start from that 365th. Actually, it is going to be 366th data point. Okay. From there, I will go all the way to my data. What was the name of the data? Data 2. Data 2 dot shape 0. Okay. So, okay, all right. Next, what I'm going to do is I'm going to, this value is data so for that, it's going to be easier if I turn my data into a numpy array. So let's do it this way. X is data 2 times values. So let's see how that looks like. Okay. So data 2 dot values. So when you make this, it's actually, we are turning this data to type, the dot values is giving us an array of turning our temperature value into an array. So I think it's going to be easier if we just loop over an array. So that's why I chose that. And then let's make this x dot shape. And then let's make this x. So if I want to say this is x, again, I want to try first so that we see what we are doing. So if I say x 0, this is the first element of my x. Okay, so if you do this, it is giving you the first 10 elements. Okay, so x of I minus x of I minus here. Okay, so sorry, I'm subtracting today's temperature from exactly 1 year later. I is 365. Today is 0. Okay, this is the value. And then if 2 append with this value, and then let's now plot this difference. PLT dot plot diff. So worked. Yeah. Okay. So it looks like we eliminated some seasonality here. So there is still, I can see that the figure is moving up and down. There is still something going on here. We are going to do our best to also deal with that. But a couple of things here that we need to consider. One thing is, if you look at the data, okay, so we have to be very careful when we are dealing with data sets, right? So we should think a little bit deeper. If you look at the data, it is daily data, right? And what is the size of the data? It is, if I take the shape of this data and divide it by 365, so it is a 10-year of data. It's a year of it's data collected over 10 years. So remember leap year. What is leap year? From every 4 years, right? February is taking 29 days, right? So in that case, if February is 29, and remember we are trying to eliminate seasonality, here I don't think it's going to have a huge impact. I don't think it's going to have a huge impact, but we have to consider that, right? So basically, with the leap year, we are actually subtracting today's temperature from next year's tomorrow's temperature, right? In that case. So, and then there is another leap year. I think there are 2 or 3. We're going to check it. So that way, we actually shifted. It's not going to be too different because today's temperature is not so different than tomorrow or the day after tomorrow. That's why we are not going to see too much of a difference. But I just wanted to bring this to your attention that that we need to be careful when we are dealing with time series data sets. Okay. Regarding the temp trends, how come it reaches around its max in the middle of the years? Regarding temps trends, how come it reaches around its max in the middle of the year? That's for temperature. I mean, in the middle of the year, probably this is corresponding to. Oh, I see. So this temperatures from Australia. I think it makes sense, right? Okay. Yeah, if you like, I mean, this is a little bit coding, but if you like, let's find this if we have any February 29. So I tried to find that actually. So let's see. So what we're gonna do is I'm gonna take my data. Again, this is just an exercise. Okay, my data. If you check the index of your data, index is the years, right? So again, this is the date time index. Okay, these are the years, which is an index of your data, and then your indices are in date time format. So in that case, I can take my index and then select month directly. Because it is date time format, I can focus on month or I can focus on the day. So what I'm going to check is if the month is 02. Okay, I'm just checking if the month is 0. Of course, this is going to be just 2. So if the month is 2, and also I'm going to check. Let's use and I'm going to check if my data to index, and then this time I'm going to pick the day part of it. Okay, if it is equal to 29. So this way I'm checking if my data set has February 29, and that's what I want to see. How many times? So data to okay. Yeah, let's see. Oh, it says 3650, right? So that let's see, Carl. Let's see. Yeah, that's also, yeah. So I have, interestingly, I have 2 years with 29. Then how come I have exactly 10 years? Probably maybe the last 2 days is missing. So let me see. Yeah, these are all things that we need to have. Oh, it's starting from the beginning. Let's check the tail. yeah, it's interesting that even though I have two 29s, right? So the size of the data set is exactly 365 times 10. So it should be 360, 52, right? 36, 52 at least. Yeah, I'm not sure what happened here. I'm not sure what happened here, but at least I called these two guys. I should have had, right, 360, 52, right? That's what it should be, not 365, 36, 50. Anyways, so this is one thing that I just wanted to bring to your attention. If you like, you can eliminate these data points and then do the same exercise. So subtracting exactly from 365, you'll see that it's not making too much of a difference, okay? It's not making too much of a difference. All right. Yeah, it's every 4 years. And so in a 10-year period, it's only 2 leap years. I agree with that, Christopher, but my data points should be 3652, right? Because in the leap years, we have 366 days, right? Not 365. Am I correct? Or it's been a while since elementary school. I forgot about this, but I think we should need 2 more days. So that's why I was surprised. Okay, so I had some other things in mind that I was going to talk about seasonality, that we can also fit a polynomial model to our data set. Actually, maybe we can try that polynomial model. So I had a little bit more stuff in here where we can work on, but again, we are having less and less time for stationarity. Maybe. Okay, let's do it this way. Let me leave stationarity to our next meeting. I think it's very important. And then in our next meeting, I can also add one more. Maybe we can start to looking at AR model, maybe together AR and MA model if we can. But let me leave stationarity to our next meeting. All right. Maybe check for month 12, day 31. Yeah, that's also another thing we should look at, Carl. Yeah, I didn't check that one. I didn't really check I didn't think about this. Now you said I began to think about it. Okay, let me stop here, guys. I think we got tired. Let me stop here. I'm going to continue with stationarity in our next meeting. What we covered today was removing trend, finding trend, removing trend, and seasonality. And we did some Python, Pandas, NumPy exercise, date time exercise. I think it was useful. And in our next meeting, we are going to talk about stationarity. And hopefully, we're going to start talking about MA as well. Okay, so let me stop here. Thank you for listening. And I'll see you guys next time. Take care.